Hello students, how are you? So in this video we would be discussing about the friction. So frictional forces acts when there is a object and there is some another object or something on which the other object slides. So if this object is sliding and there is some friction over there, so this will create an opposite force which will try to reduce the speed or try not to move the object. So if this object tries to move, if we put some force to move this object, this friction will cause some hindrance in the movement. So that's why the first thing is that frictional force is always opposite to the motion of the object. Second thing, the area of contact. Suppose this object is like this. So downwards at the bottom. So this is the area that is in the contact with the table. If we draw like this is the table. So this is the area. So if the same mass of the object has area like this, now you can see that the area has increased up to much. So this is the whole area. So in general we can say that area, that if it will be larger area, it will create more friction, but it is not the case. In friction only depends upon the mass and the frictional coefficient. If we say that the frictional coefficient here is 0.3, here also 0.3, here also 0.3, the frictional force will be same, and it depends upon the normal. What is normal? We have already discussed that this will be mg and above it will be normal. Normal is, in this case, it is equal to mg. Do not write this formula like this. I have seen that many times students write formula like this. This is not right, but this is not the this is not wrong, but this is not the right way to write it. You always write mu n. Then you say that n is equals to mg, because there would be questions like this. So once there will be some theta over there, so this will be mg and this will be normal. So now this normal is not equal to mg, but normal is equals to mg cos theta, because this will be cos theta, mg cos theta. So this is the basic discussion for the friction. Now we would be discussing about the types of friction. See, there is two types of friction, that is static and dynamic. Static friction is the friction that when the object is not moving, that is static friction. So if it says that this is 0.3 static friction and weight is 10, like I'm writing it mg whole. So the maximum friction that can act on it is mu n, which is 0.3 into 10, so it is 3 newtons. So 3 newton is the maximum value of static friction on this object. So if we are applying here 1 newton, that is the force applied, so the frictional force will become 1 newton. So this static friction is self-adjusting. So if it is 2, it becomes 2 newton. If it is 3 newton, it becomes 3 newton. And at the 4 newton, when we have applied more force, this object will start moving. So at what speed or how it will move, that depends on the dynamic friction, that is mu d. And mu d is generally smaller than the static. So if we say that it is 0.2, so it means that then 2 newton will be applied as dynamic friction. So this is up to the static one. After that there will be dynamic friction. So now when you will apply 4 Newton here, it will be giving you mu into n, that is 0.2 into 10, so 2 Newton will be there, so friction will become 2 Newton. So if you will apply 5 newtons now, then also friction will become 2 newtons only, whereas the F net will change. So this will give you 2 Newton backward, and you are now applying like 4 newtons, then 5 newtons. So if you will increase your force on the object, the net force will increase. So it will be 4 minus 2, that is 2, 5 minus 2, that is 3. So it will go on increasing. So as the force will increase, the acceleration will increase, because F equals to ma. So we will divide this force with the mass and we will get the acceleration for that. So this is the all about the friction, the static friction, dynamic friction, and now we will do one graph also for that. So there would be some questions from that graph also. The graph is also very important. So in that case, the graph says like this. The axis, there is like, if you will start applying, it will go like this. So this is the time period, or like no motion here. So as you are putting the force, we are putting some force over there, like 1, 2, 3. The static friction is increasing. So static friction went up to this. That is the 3 Newton. And once the body started moving, it came back to 2 newtons. So this is the static friction, and this is dynamic friction. So dynamic friction is constant, whereas static friction is increasing, and just after it has now started moving. So here up to this there is no motion, and after there is motion. So there could be some questions from the graph also. So this is all about the friction, and one portion is still there, that is the angle of repose. We will do it here only. Okay, now you see angle of repose, and then after this angle of repose our friction topic will be completed. So angle of repose is like, suppose this is the object and now you have tilted this object like this, so this is the theta. So angle of repose is the maximum value of this theta, that this object doesn't move. So if this object will be moving downward, this friction will be on the opposite side. So there will be Fs. So this will say to move, come down. As we will move, tilt the object more, it will try to move this object downwards, but this friction will try not to move this object. So here Fs, that is the maximum value, will be equals to mu s and r, or r we can say that is the r or the normal, whatever. R is reaction, or generally we use normal also. So now what will be, so this will be mg, and this will be mg cos theta, and this will be mg sin theta. Okay, I think that you know it. So this will be the force, so mg sin theta will be equals to mu s, and normal is mg cos theta. So this mg and mg goes off, so and this becomes sin theta upon cos theta equals to mu s. So sin theta upon cos theta is tan theta. So tan theta equals to mu s. So theta is equals to tan inverse of mu s, like this. So this is the angle of repose. Okay, so this is like the object was here, this force was pulling the object downwards, and friction is making the object static. And this is the maximum value that a friction can have. So this is the theta. So many times there would be questions that what is the maximum angle that we can have when we will be tilting. So with this, we have completed the friction part. There would be many numericals which have different logics there. So it needs a lot of practice. So if you have any doubt with that, some questions you are not able to solve it, you just comment it here and then we can work on that. You can also join to me with one-on-one classes. So thank you for being here.